Hi, my name is McKenna Greenwood, and I play alto saxophone in the 6th grade band. We are playing Storm Chasing, written by William Owens. This song is supposed to sound like a storm. Please listen for the sounds of rain throughout the music. Please enjoy the song. Thank you.
Hey everyone, it's Mrs. Kincaid here. I was just listening to one of the pieces that you guys are going to be performing at the Band-o-Rama titled Comet Ride. Mr. and Mrs. Brown asked me here today to give you guys a mini lesson on comets in relation to the piece that you guys are going to be performing. So, before we get into this lesson, I kind of want to give you guys a little bit of background on the piece itself. So, Comet Ride was composed by Brian Belmages, and his backstory is quite interesting. He studied music, and when studying music, he met a lot of people that went into music education. So, a lot like Mr. and Mrs. Brown, they went to school and they ended up going into music education, and that's why they're there teaching you guys every single day. Well, Brian had no intention of going into music education, but he was always working on music. Even way back when he was in school, he was always composing and writing new pieces. Later on in his career, he had several of his peers reach out to him and ask if he would be willing to compose something for their classes. So it's quite interesting that at some point in his career, he was working on pieces for education purposes, and here you guys are today playing this piece for school. So, a little bit more about the story behind the Comet Ride. So, when Brian created this piece, he wanted you to consider this scenario. What would it be like if someone could actually grab onto a comet and take a ride through the solar system. So, through this piece, this is the story that he wants you imagining. Now, we're going to dive in a little bit into some comet basics. I have a feeling that some of you might have a basic understanding of comets, so this might be a little bit of a review, but for some of you, you might not know any of these details, so you're going to learn something new today. So, our first question is, what is a comet? So, comets are large objects made of dust and ice that orbit the sun. Best known for their long streaming tails, these ancient objects are leftovers from the formation of the solar system 4.6 billion years ago. So, where do comets come from? Comets typically are found in the distant solar system. So, here on the left hand side, I have an image of essentially our solar system. So, right here in the middle, we have our sun. And then we have Earth just outside, right? This is where we are. And then there are two circular items on the outside. And these are the two pieces that we are going to talk about today. So, first, we have the Kuiper Belt, which is just beyond Earth, right? So, a little farther. And this is where some of our comets exist. Typically, these comets are titled as short period comets, which means essentially they take about 200 years or less to orbit fully around the sun. Next, we have the Oort cloud. So even farther beyond the Kuiper Belt, it is about 50 times farther from the sun than the Kuiper Belt itself. But this area houses our long period comets because they take much longer to orbit all the way around the sun. The comet with the longest known orbit took about 250,000 years to make just one trip around the sun. So, definitely a lot longer period of time. What are the parts of the comet? So, here we have a little diagram, and we're going to start right here in the center, or the heart of the comet, the core, which is known as the nucleus. This term should be familiar. We all learned about this in our cell unit at the beginning of the year in science class. Next, we have just outside the nucleus, this is called the coma, which is essentially a round circular dust or gas, a fuzzy area created right outside of the nucleus. Then, two other key important parts of the comet are their tails. So, we have two different types of tails. We have the ion tail, which is a result of solar wind pushing gas out from the comet. And then we have the dust tail, which is the component of the comet's tail that is composed of dust particles. So, how do we learn about comets? People have been interested in comets for thousands of years, but it wasn't possible to get a good view of a comet's nucleus or all of its different components because the moment it hit Earth, it essentially shrouded by the gas and the dust of the coma. So we were never able to really get the details. But in recent years, several spacecrafts have been able to get the chance to study. We know science is always changing, we are always advancing, and we're always learning more things. Now, I know this was just a basic introduction to comets, but I hope you learned something new today. I appreciate you taking a moment to learn a little bit more about comets today. And although we may never be able to ride a comet in our Earth's lifetime, we can imagine it while playing and listening to Brian Pelpage's work.
Hi, my name is Ellie Thomas, and today we will be playing Comet Ride. Comet Ride was written by Brian Pelpages and was released in 2011. While we play this song, imagine you're riding in a comet into space. Thank you for listening, and I hope you enjoy Comet Ride.
Hello, my name is Miley McCauley. I play bass clarinet in the 8th grade band. The next song that we'll be playing is Terminal Velocity by Tyler S. Grant. Something to listen for is the tempo change throughout the song. Please enjoy Terminal Velocity.
go.
Hi everybody, I'm here to show you an example of refrigeration with some liquid nitrogen and air filled in a balloon. So if you think about the balloon, it's filled with air and those particles are moving around really fast right now because it's room temperature. It's pretty warm in here. I'm going to dip the balloon into liquid nitrogen and we're going to see what happens to the speed of those particles inside the balloon. Here we go. Okay, so as the balloon is dipped into liquid nitrogen, those particles start to slow down because liquid nitrogen is really cold. Okay, it might look like the balloon is deflating, but it's not. It's still sealed. I'm not letting any air out. It's just those particles are starting to slow down and they're not bumping against the sides of the walls of the balloon with as much force anymore. All right, I'm actually going to speed this process up by dumping some liquid nitrogen over the top of it. Okay, so if we look at it, look at that. It looks like it's completely deflated. Nothing left in here. But there's still particles in there, they're just moving really slow. So if I bring them out, we'll see them speed back up again. All right, and we're pretty much back to the original shape. Okay, so example of refrigeration where we have particles slowing down, speeding up. Thanks everybody for watching the demonstration on refrigeration.